50,000 bridges in France, 8 million square meters. In more than one respect, an important part of the nation's heritage. Yet, this is not inanimate. It lives and deteriorates because of heavy traffic, water and frost. It can also perish. Remember Tours in April 1978. As with the rest of the highway network, surveillance begins at construction level to establish a baseline. Visual inspection is a primary means. Most frequently, manholes are provided for access to the internal parts of the structures. It may sometimes be necessary to provide inspection footbridges. This allows for proper surveillance of zones that are hard to reach. Defects may also be detected, signs of aging. A new means of investigation has now been added to the set of tools available to the Ministry's technical staff. Scorpion. This somewhat unattractive French term rather hides the fact that the system is intended for the radioscopic inspection of concrete structures. Let's pass over the alchemy of the words and hail the technical achievement. Scorpion may be used to produce either radiographs or direct images of the internal structures of concrete walls. In other words, it makes it possible to see through structures and carry out a continuous, non-destructive examination in real time. The heart of Scorpion is a linear particle accelerator mounted on the end of an articulated telescopic arm and carried by a 36.5-ton semi-trailer that does not exceed normal highway clearance limits. It can move in 3 dimensions and is capable, for example, of reaching an extreme position 6.5 meters below the pavement level and 8 meters behind the parapet. It can also travel 7 meters longitudinally on the trailer. The linear accelerator is a miniaturized Neptune 4 weighing 250 kilograms, designed by the Compagnie Générale de Radiologie MEV. The entire accelerator carrier vehicle was built by the Ministry's Design and Prototype Construction Center at Rouen. So much for the source. For reception, the detector must now be placed inside the box structures of the bridge to be examined. This detector uses a converter suitable for high-energy radiation, developed by a research team at the Blois Public Works Regional Laboratory. Patents have been applied for in Europe and the United States. the converter transforms the X-rays emitted by the accelerator into visible images after they've passed through the thickness of concrete to be examined. The image is then recovered and analyzed by a very sensitive Thomson camera tube and signal processing electronics developed by Sofretec. The design and application of this televised radioscopy system called for the construction of a mechanical device capable of ensuring perfectly synchronous movements of the accelerator or radiation source and the detector. This mechanical device, which required precision as well as reliability in operation, was designed and built by the Design and Prototype Construction Center at Rouen. Once the electrical connections are installed, the various signals are transmitted by cables. All control and data acquisition functions are centralized in a laboratory vehicle, the installation's brain. The vehicle also has a darkroom to develop radiographs. Naturally, safety regulations require constant surveillance of the test site. Finally, the whole area is signposted. The intensity and energy of the emitted flux of X-rays are very large. Scorpion makes it possible to examine concrete up to 80 centimeters thick by radioscopy and up to 120 centimeters thick by radiography, and so to detect cracks and heterogeneous zones and locate reinforcements and pre-stressing wires and their sleeves, and check that they've been properly grouted. Visual examination of the image on the monitor is backed up by recording on a videotape recorder, used in conjunction with a character generator. Data acquisition is in real time. Another great advantage of radioscopy is that the image moves and is not frozen like a radiograph. The zones to be examined can be inspected from different angles, and the planes of observations rotated for a far more precise examination. Excellent image quality, rapidity of use, and instantaneous readouts are all great assets for Scorpion. Its potential market is vast. Public and residential buildings are both likely to require regular surveillance. It may also be possible to use Scorpion to inspect welds in metal structures. In short, a new system, one that offers incomparable performance, has been added to the arsenal of inspection equipment already available. And someday, we may be able to say, concerning the management of our bridges, yes, of course, but that was before Scorpion existed.